Hello, and welcome to your OSL640 Week 9 Lesson 1 video, where we're going to look at regular expressions in comparison to file name expansion, which we did previously, and we're going to look at some fairly simple regular expressions. We're going to look at some more advanced regular expressions in the second half of this, the second lecture video. Simple first, we'll get into some more advanced stuff. So we're going to look at what are regular expressions first of all, because you may or may not have heard of them, and I'm expecting probably not. We're going to look at how regular expressions work compared to file name expansion. We're going to look at simple regular expressions using grep, more complex regular expressions also using grep. You'll get a demonstration of both of those, and all of this will map to your Week 9 tutorial, Investigation 1, and your review questions, simple and complex regular expressions, parts A and B. Now, before we get too far ahead of ourselves, I want to stress that I don't expect you to master regular expressions in a week, because that would be crazy. You're going to get an introduction to them, and we're going to play around with them for the rest of the semester, on and off, with some other commands as well. But regular expressions can be tricky. They can be they're strange in the way that they work. And the easiest way to get the correct one for the particular case or use case that you're looking for is to just kind of do it and figure it out and observe the output, try it, get it wrong, see what you need to modify. You'll probably notice I've got prepared examples for you, and I'll still probably get some of them wrong. In that I won't get the output that I was actually looking for, and I might have to modify them. It's very, very common. So don't panic. So what are regular expressions? Well, they're simply a sequence of characters that define a search pattern. Now, you usually use search patterns for searching strings, for find or find and replace operations, or for validating input, either from a command line or from a form in the case of server-side scripting. They're used for all kinds of things. And in all honesty, any good programming language supports regular expressions. Even some of the server-side scripting stuff, like PHP and Python, I know both do. You can use Python for everything, not just programming. You can use it for Linux scripting. You can use it for server-side scripting. You can use it for a bunch of different things. Anyway, so we learned about file name expansion, right? Where we used special symbols that allowed Linux to expand file names as arguments, which we talked about as globbing, right? And we used that with a variety of commands: ls, rm, move, copy, cat, less, more, head, tail, sort, unique, grep, translate, cut, and word count. And others probably support it too. That's just like a short list of ones offhand that do. Regular expressions are kind of like file name expansion, although some of the characters don't work quite the same. So you're going to have to kind of play around with that to figure out what does and doesn't work the same. But they're used to search and manipulate text and edit text. Now, that text could be a file, or that text could be other input within a pipeline command. So you could actually take the output of something else, pipe it into something to search for a regular expression, usually using grep or egrep, but sometimes using sed or awk, which we're going to look at later in the semester, and do some stuff with that. And you can do some really, really powerful things with that. The simplest regular expressions that we can possibly write are looking for literal patterns, so exact words or phrases. So the examples here are, we have document.txt, and it has these lines here. And we could use grep on that document and just search for Linux. Grep Linux document.txt. We've done this sort of thing before, right? When we looked at grep, that's using a regular expression. It's just our regular expression is like a literal word in that case. You can do this with a pipeline command too. You could do an ls and pipe it to grep. You could do a who and pipe it to grep. And if you've got a lot of output there, you might want to pipe it to a more or a less or a head or a tail, depending on what output you want to narrow down your depending on what output you're trying to capture, right? To narrow down your results. That's what I was trying to say. So you can use grep in this sense as a filter to match things either from standard input or from the output of another command. Let's look at some really simple regular expressions. So I've got a file here called cars.txt, and if I look at the content here, I think we used this in a previous lecture. I don't remember, but if you you need a copy of it, you can. It does that sometimes when I cat the contents. You can copy it. It's in my public HTML directory, so you should be able to cp home my name public _HTML cars.txt, and just, I'm not going to execute this command, but just go to your directory that you want it to be in and just copy it right there. So we've seen what's there. Now let's look at some basic regular expressions. We're going to look for Chevy in cars.txt. Now notice we've got Chevy with both an uppercase C and a lowercase c. So if we're searching for Chevy with a lowercase c, well, we're going to see all the matches with the lowercase c. If we're looking for uppercase C, we're going to see all the matches with an uppercase C. Not particularly useful with basic regular expressions. And we could also just search for, like for example, the letter C, and that's searching for it anywhere in the file, so a couple others popped up. It's not looking for it at the beginning of the line or the end of the line or anything of that nature. It's just looking for the letter C. Regular expressions are very greedy that way in their nature. They will match as many of that thing anywhere they can in the line. So there's some simple ones that may not give us the exact output that we're looking for, depending on what we're looking for. This is kind of a silly example. But we're going to learn how to narrow these down in the next few slides. So stick around and we will continue on. So you may want more precise pattern matching, right? For example, if you're looking for, we saw a silly example with Chevy. But if you're looking for the word the, just as an example, it would match any occurrence of those three letters in any other word they are embedded in, including the word the. So there, either, them, the other, there. There meaning, of course, over there. They meaning, usually referring to another person, and there usually meaning like this belongs to another person, right? And there's also other types of patterns we might want to search for. Like we might want to search for a particular pattern in a particular location within the string, either at the beginning or at the end. Or maybe we want it a certain number of times. Or maybe we want it a range of characters, like a range of numbers or a range of letters, which is where we would use a character class. Or the number of occurrences that pattern appears. So we can use extended regular expressions and some complex ones. We're going to look at complex in this lesson. We'll look at extended in part 2. To make these really quite flexible. So in complex regular expressions, we can use some symbols to help make our regular expression a little more versatile, right? We can do things like anchor the string that we're looking for to the beginning or the end of a line with caret or $sign. I think we get into these individually. Yeah, we can do things like look for any single character, or any character from a range of character, or not in a range of characters, or we can look for occurrences of a word, 0 or more occurrences. We'll look at each of these individually. Although I just kind of told you what they did. So if we want to anchor a search string to the beginning or the end of the line, we use a caret, which is shift and the number 6 on your keyboard. Also sometimes referred to as a little hat, right? And that will anchor the pattern to the beginning of the line, or look for it at the beginning of the string. If we want to anchor it to the end of the string, we use a $sign, and we place these either at the beginning or at the end, depending on what you're looking for, of the regular expression. So if you're looking for it at the beginning, caret and then whatever you want to look for, and at the end, of course, $sign goes after the thing that you're looking for. So for example, grep caret beginning in this data.txt is going to match any line that has beginning, that exact phrase again, at the beginning of the line. And it's not going to match this one in the middle, and it wouldn't match it anywhere else. This one here is going to match any line that has the word end right at the end of the line, and nowhere else. So hopefully that helps, and of course we're going to look at some examples of this, so don't panic. We can use a period or a dot to represent a single character, any single character. So for example, we could combine this with the things that we just learned about anchoring things, right? So if we're looking for lines that only contain one character, we could use grep caret, so beginning with a single dot, a single occurrence of anything, followed by the end of the line. That would mean one character. And that would give us, in this particular context here, the line that has just the capital letter I. If we want, of course, more than one character, we can just put more dots. So this would be 5 characters and only 5 characters, so it would match hello and isn't, but not anything else. Interesting, I think. We're going to see some more practice examples of these, of course. And don't worry, like, your tutorial is going to take you through a whole bunch of these. So that's all well and good, but what happens if you want to use like a range of characters? You want to look for numbers or letters, or numbers or letters within a certain range of parameters. We can use a character class. It's kind of like the single character, but with restrictions. And you can even include the caret inside the character class, and that will invert it. It means the opposite of whatever you've put in there. And of course, you can use these in conjunction with anchors as well. So searching for this one here, grep caret, so the beginning of the line, followed by A to Z, so in square brackets. We have that 3 times, A to Z, A to Z, A to Z. That's going to be lines beginning with 3 letters, 3 lowercase letters, right? In our data.txt file, so that would match this here. Grep, we've got the caret on the inside here, and so we've inverted this. A lowercase a to z, or an uppercase a to z. $sign, so we're anchoring that to the end of the line in our data.txt. It's looking for lines that do not end in 3 lower or uppercase letters. So anything else. Hopefully that makes sense. And again, we'll look at some more examples. We're getting to the example part. You can use an asterisk or a star, which is shift and the number 8 on your keyboard, to look for 0 or more occurrences of whatever comes in front of it. And that's the important part. 0 or more occurrences of the previous character. It doesn't work like an asterisk in file name expansion where it means anything. It has to have something in front of it for it to make any sense. So if you wanted 0 or more occurrences of anything, you would have to have a single dot and then a star. So examples here, we've got this data.txt file here that has a bunch of lines in it. grep Linux space I star would match Linux, followed by a space and 0 or more occurrences of an I. And that's going to, of course, match these because they begin with Linux. grep is, and it should be a lowercase here. I don't know, something funky happened with autocorrect. Lowercase I star s, so a lowercase I followed by 0 or more occurrences. Sorry, s. 0 or more occurrences of a capital I followed by an s. Space an will give us Linux is an OS, and Linux is with a typo here, 2 I's, an OS. And finally, this one here isn't going to match anything, but what do you think that would match? You can pause here and see if you can figure it out. I'll give you the answer. So we're anchoring it to the beginning of the line, 0 to 9. So beginning with a 0 to 9, followed by star, dot star, so 0 or more occurrences of anything, and ending with a 0 to 9. So it would give us a number at the beginning, a number at the end, and anything in the middle. 0 or more occurrences of anything in the middle, including 0. So it could be 2 numbers, which we don't have in this file. Let's look around and play around with some of those, because I think you've heard me talk about it just enough. You want to see it in action. So I'm just going to clear my screen. To keep things simple, we're going to be working with that cars.txt file throughout every sample I give you here. And let's put it on the screen again. I don't know why it does that. So we're going to look for grep lines beginning with an uppercase C. And there we go. We get Chevy. Beginning with a lowercase c, well, we get Chevy there, right? With the lowercase. What if I wanted beginning with an upper or a lowercase? And there we go. Now we get all occurrences of Chevy. Isn't that interesting? We can also do beginning with an A or H, so anything between an A and an H. Or we can invert that and do not. So we get anything that's not a lowercase a to h. And with that one, I think you can appreciate how complicated some of these can get, because we're doing some fairly simple things. They're already getting a bit complicated. Let's say we want to look at lines that end in anything but a 0. So we could do 0 to 9. $sign to anchor that to the end of the line. Sorry, not 0 to 9, 1 to 9. 0 to 9 would give us 0 as well, right? We could also do not 0 at the end of the line. So there's different ways of doing the same thing. As you'll find, there's often more than one way to do the same thing. A couple more, and then we're gonna be done with this section anyway. So a 1, 0 or more occurrences of a 1 now, followed by a 0 at the end of the line. In cars.text. And see, we get a whole bunch of stuff. Well, what if we were to put a dot here? Does that change things up a bit? It does. We limited our output a little bit, and we get a whole bunch of numbers here. Because we're looking for something that begins with a 1, right? So any line that doesn't have a 1 in it now, we don't get it. And last one here. This one's going to build on things for our next set of slides, possibly in our next video. I think it's in our next video. We're going to have to look when we get there. So we're looking for 0 to 9. This one's going to get a little complicated. 5 times. So 0 to 9, 0 to 9. It's 3, 4, 5 at the end of the line. And there we go. We have totals here that are 5 digits only in our last column. We're going to look at a more advanced way to do this in our next set of slides, our next set of demos. It's a good idea to create a reference sheet, so you can do this and write out your separate special characters on that sheet of paper. I think there's also one on the wiki, and if there isn't, I'll add one. But here's a good start right here. And this covers everything that we've talked about thus far. And look at that, we're at the getting towards the end. So you're going to get some practice with everything that we just looked at in your Week 9 tutorial, Investigation 1, and the practice questions associated with that. So with that, take care, and I will either see you in the next video in a couple minutes, or you will see me again in the next video when you sit down to view the your part 2, right? Take care, be safe, and I will see you in the next video on Friday. Bye for now.